In today's lesson, we're going to take a stroll into the world of separation techniques. Remember, in our previous lecture, we discussed about mixtures and compounds, as well as elements. Yes, and then do you remember when we talked about how compounds and mixtures are made from a combination of individual constituents in the bid to be able to split these compounds and mixtures into their individual parts? We'll be looking at the topic separation techniques. Now, separation techniques, as the name implies, separation. What is separation? If I have a mixture of clothes, probably a mixture of dirty clothes and clean clothes, and I want to separate the clean clothes from the dirty clothes, simply what I'll do is pick out the dirty clothes or pick out the clean clothes. Now, the process of separation is simply picking out or dividing a particular substance into individual parts. So, if I'm able to separate a substance into individual parts, I would say that I've achieved the process of separation. Now, coming to chemistry, because we have compounds and mixtures which are formed from individual constituents, don't you wonder how these compounds and mixtures are separated into their individual components? We say the essence of separating mixtures and compounds is first to get a part of that mixture which is of importance, right? An active ingredient, like I said. And then another reason we use separation techniques is for purification. Remember the example I used earlier where I said if you want to separate clean clothes from dirty clothes, right? You basically pick out the dirty clothes. So you could actually purify substances by removing the impurities. And that is also a separation technique. So properly, we'll go into separation techniques in chemistry. I define separation to be the splitting or division into what individual constituents or parts. Now, I'd like us to note that every separation technique or every separation method in chemistry requires or is dependent on the properties of the constituents of that particular substance. Now, when I refer to substance, it could either be a mixture or it could be a compound. And if you could remember in the previous lesson, we said mixtures are physically bound together. So they could be separated by physical means. Yes, we could use ordinary physical methods in separating mixtures. On the other hand, compounds, which are chemically bound, the constituents of compounds can be separated by chemical means. Note that every method depends on the property of the constituent. What do I mean? If I have a mixture of solids, let's take for instance, I have a mixture of rice and beans, and I want to separate my beans from my rice. Now, I would consider the fact that in using a physical process, which is hand picking, I could easily pick out the larger sizes, which is the beans. I could pick out the large sized solid or particles, which is the beans, leaving behind the rice. So the property of size is considered in this process. Looking at the separation techniques in chemistry, there are several properties we consider in using these methods. So we're going to look at those properties. Now, the essence of knowing this property is that it would help you identify the specific process that works for a particular substance. So when I know the property of the constituent of this substance, it helps me in easily identifying the technique or process that would suit the separation of that substance. For instance, let's take magnetic property. If I have a mixture of particles of magnet and sand, first thing, what can easily pick out magnet? You're looking at the magnetic property. So what we do is we get a bar magnet, simply place it over that particular mixture. You figure out that the bar magnet actually attracts the particles of magnet from the mixture because the particles of magnet have the magnetic property, right? So the bar magnet can easily attract the particles of magnet, separating it from the mixture of sand and magnet. Other properties we could consider in using separation techniques are boiling point. We also have vapor pressure. Now, vapor pressure actually determines the rate or level of volatility of a particular substance. So when we say a substance is volatile, it could easily transform into the gaseous state. We also have density, permeability. Mean permeability, what am I talking about? Permeability is simply a term that describes the ability of a substance to pass through a porous material. When a substance can pass through a porous material, we see that substance is permeable. Porous materials like cloth, some certain kind of materials that are used in sieving. Do you remember the traditional sieve that is used for producing pap? There's a particular cloth you see the people who make pap use in sieving the pap substance or the substance which the pap is to be gotten from. Now that particular material is considered to be a porous material. In this case, what actually passes through that material is permeable. A solid can not easily pass through that material. Most times we have that liquids or solutions pass through porous material. So permeability is one of the properties we would consider in using separation techniques. We also have the rate of movement of a particular substance along or across an absorbent material. So we say rate of movement of particles. We also consider the melting point. Having looked at the properties to be considered in easily identifying the separation technique that could be used in separating substances, which could either be a mixture or a compound. Any method of separation could either be by physical means or by chemical means. Now we're going to look at these separation techniques. But before we go into the separation techniques proper, I would like us to note that not all separation techniques could be used for every substance or every mixture or compound. Now we have specific methods or techniques for specific substances. Remember, like we said, the property will determine the kind of method to be used in the process of separation. This brings us to the category or types of substances under which these separation techniques are classified. So we have that in the category of the separation techniques, we have what we call the substances or mixtures that come in the solid to solid form. So we have substances in the solid to solid form. Could give a whole lot of examples. Like the example I gave earlier about the mixture of beans and rice. You can see that both substances or both individual parts are what? Solid. But then they're solids of different sizes. So size is basically a property to consider. But here we're looking at the category of how these separation techniques are classified. So any separation techniques that will be used in separating that mixture will be classified as a solid separation technique. Now, if we have, for instance, sugar and beans, both solids, and we use sieve, which is a sieving process, you can see that you're actually separating a mixture of a solid to solid form using the property size. Now we're looking at another category of separation techniques that actually help in separating solutions. These categories of methods or separation techniques help to achieve the separation of what? Solutions. So we could have a solution of milk and water. They are mixable, so they are homogeneous. Solutions are considered to be homogeneous substances. Moving on over to the next category, we have the category of an insoluble solid to liquid. Now, every separation technique classified under this category aims at separating either the insoluble solid from the liquid or the liquid from the insoluble solid. So it's possible that we can extract our insoluble solid, or we could decide what we want to recover in this particular mixture is the solvent, which is the liquid, of course. So the insoluble solid to liquid category does the separation of that particular kind of mixture. And the last we have is the separation of immixable liquids, right? Immixable liquid, a mixture or substances that are immixable. When we have substances that are of distinct layers, although they are mixtures, you could visibly see that these substances separate into different layers. Remember when we talked about homogeneous and heterogeneous substances in our previous lesson? We said homogeneous substances contain the same kind of matter. They don't separate into phases or layers. They have a distinct layer. On the other hand, heterogeneous mixtures or heterogeneous substances contain different kinds of matter or states or phases of matter. So we have that immixable liquids to liquids have different or distinct states of matter. So we could use any separation techniques that falls under this category to separate immiscible liquid. So you'd wonder why I have to categorize these separation techniques. It's just for your easy understanding. So if I take a mixture of oil and water, and then when looking at this mixture, I see that, oh wow, oil doesn't dissolve in water. So this should be an immixable liquid, right? So I'd have to rewind my memory and go back to methods or separation techniques that fall under the immixable liquid. So I could pick a separation technique that actually falls under this category, and then it would help me in separating that particular mixture of oil and water. Now that I've been able to understand clearly how we could easily identify separation techniques that could be used for different substances, I look forward to seeing you in my next class, where I'll definitely go into the different kinds of separation techniques and give you concise examples on how they are being used. If you have any questions or comments as regarding this class, you could kindly drop them on the comment box. See you in the next class.